Use the definition of the derivative to calculate the derivative of some families of functions. Now let's use the definition of the derivative to show that some functions don't have derivatives at certain points. So the first one we're going to look at is, let's take a look at f of x is the absolute value of x. So in order to do this, from the definition, we're going to write out this limit here. And we're going to be looking at what is the derivative at 0. So we're going to compute out the limit as h goes to 0 of f of 0 plus h minus f of 0 over h. Well, let's see. This reduces down to the limit of the absolute value of h minus 0 over h. So that's just the limit as h goes to 0 of the absolute value of h over h. And so what's going on with this limit is that we need to consider the two one-sided limits here. That the limit as h goes to 0 from the left of the absolute value of h over h. So this is when h is negative, so the absolute value of h is negative h. And those cancel, and we're left with the limit as h goes to 0 from the left of minus 1. So that answer is minus 1. When we do the limit as h goes to 0 from the right, we have the limit, so h is now positive, and so we end up with h over h. Since h is positive, the absolute value of h is just h. So we're taking the limit of 1, which is 1. So the limit from the left is minus 1, the limit from the right is plus 1. And so overall, we see that this limit doesn't exist. So we should have said here, f prime of 0 equals what? That's not right. We just want to say f prime of 0 does not exist, or f is not differentiable at x is equal to 0. That's equivalent to saying f prime of 0 does not exist. Just to sketch a quick picture here to explain what's going on, let me draw some axes here. Okay, so the sketch of our function, here's the absolute value of x. Basically what's going on here is that the slope of the tangent line as we're coming in from the left is minus 1. The slope of the tangent line is coming in from the right is plus 1. And the limit there, as we take the difference from the left and the right, that limit, the one-sided limits exist, but they're different, minus 1 and plus 1, so the overall limit doesn't exist. So hence we say here that f is not differentiable at 0. One more example of a function that's not differentiable is, let's take a look at f of x is x to the 1/3. And once again, we're going to ask about the derivative at 0. I'm not going to put an equals here because hint, hint, wink, wink, nudge, nudge, it's going to not be differentiable. But let's see that. Okay, so we have the limit as h goes to 0 of f of 0 plus h minus f of 0 over h. So this is 0 plus h, that's h raised to the 1/3 minus 0 raised to the 1/3 over h. Limit as h goes to 0 of h to the 1/3 over h, which is the limit as h goes to 0 of h to the minus 2/3. And a moment of thought should convince us that as h is going to 0, we are dividing by the h raised to the 2/3 power, So we're dividing by something that is getting really, really small. And so this limit here is infinity. But as we said, whenever we have we said back in chapter 2, whenever we say the limit is equal to infinity, that's really saying the limit does not exist. And so in this particular problem, it's more appropriate to say f prime of 0 does not exist, or f is not differentiable at x is equal to 0. Once more, let's draw the picture so that we can see what this looks like. So that's a decent sketch of what the function x to the 1/3 looks like. And so if this was more accurate, basically when I'm going through the origin, when x is equal to 0, the slope of the tangent line, so the tangent line is pointing straight up. The tangent line is exactly the same thing as, in this case, the y-axis. And so what's the slope of a vertical line? Slope of the vertical line is infinity. So that's matching up with f prime of 0 does not exist. So what's going on there? Tangent line is vertical. So I should say we don't want to say here that f prime of 0 is infinity. It's better for us to say f prime of 0 does not exist. F is not differentiable when x is equal to 0.